So hello everyone, welcome to the last session before the lunch. So we'll be talking about how to add a new OpenVSwitch action. So before we go into that, I just want to know like how many people are like familiar with using OVS, OFCTL to add a flow, or you have worked on a controller which add flows? Okay, quite a few people. I think that would be interesting. Okay, so let's start. Yeah, so Yog will be.
So I'll give just a quick refresher about what is the flow of the packets in OVS and just general structure of the open flow, so that when you go in depth, when Numan goes in depth into the code details, you can relate to it. So next slide. So this is a general flow about flow of packets in OVS. So this is like a very high level flow. So one thing to remember about this is the faster cache. So this can be considered the fast data path, and this is the slow data path. And similarly, in DPDK, you have the PMD where you have the faster cache, and that will be considered the fast data path, and that will be slow data path. So this topic about adding actions. So when you add actions, that involves adding a flow. So when you need to push a flow, you need to push a flow to the data path, and so what are the function calls, and what are the sequence of code to go through. So we'll be going through that. So yeah.
So just to add to that, like whenever let's say VM sends a packet, it goes to the data path, and the kernel data path, or in the case of DPDK data path, it looks if there is a match for that packet. Basically, it builds a flow based on the metadata of the packet, each source, each destination, and stuff like that, and checks whether it hits the fast cache. If it doesn't, then it does an upcall and it goes to the OpenVSwitch. Ovs-vSwitchd is the process which is like running in the user space, and it gets the packet and it kind of looks up in its table. It does the flow translation and figures out what actions to apply for that packet, and it pushes that flow to the kernel, and the kernel data path executes it. And in the case of DPDK, the OVS user space itself will take care of executing it. So just to brief, like when you add an OVS flow, you have two parts. One is a match and one is an action, right? So you match, you say what is your match condition you match on your packet, and what action you want to apply. Like these are some of the examples. Like if it's a packet coming from an input, and if it's an ICMP, drop it, or these are some of the examples which I've shown. So in the case of OpenVSwitch, there are certain actions which you see here, like output to a packet, or modify as each source or each destination, or IP4, IP destination. So all those things are expressed as OpenVSwitch actions. These are actually part of OpenFlow specification as well. And there is a corresponding data path action, which is like a limited set, and OVS will like translate from this to that. Okay, so now the question is like, why do you want to add a new OVS action? So one thing is that you can probably I'm not too familiar with how the OpenFlow specification works. You can contact them, like you have a new requirement, and you can go through that. Or you can also add a new custom action in Ovs-vSwitchd itself directly if you have a use case. So basically, your existing OVS actions which you want to, you have a use case, and the existing OVS actions can't take care of that. So that's why you would probably add a new OVS action. Okay. Oh. Okay, so let me give a use case why we wanted to add a new action in our case. So basically, I work in a project called OVN. It is part of OpenVSwitch. It's like a virtual networking solution which is on top of OVS. So if you take a typical cloud deployment like OpenStack, where you have few compute nodes and you are using like jumbo frames. So all your compute nodes and your VMs are having higher MTUs like 8,500 or 9,000, and they can easily talk within themselves, east-west traffic without any issues. But if you want to send the packet to the internet, to the external, right? In that case, your external node should be capable of handling such, or that interface should also be an MTU, it should be capable of that higher MTU. Suppose if it is not, then what would normally happen is the packet, like from this VM, suppose it goes to the gateway node and it will send it up. So there, if this particular interface has a lesser MTU, the packet like silently gets dropped by OVS. So that is the present scenario in the case of OVN. But if you take normal, the reference OpenStack Neutron implementation where they use agents, there it is handled properly because all the routing is done using kernel stack, and the kernel stack running there will send a ICMP reply to this VM saying that you need to defragment the packet. So that is which is missing. So that's why we thought like we need to handle this, and we need OVS support to do that. So basically we thought, okay, let's add a new action, and we discussed with the OVS community about that. Okay, so in case like you want to add a new action, right? The first thing I would say is like talk to the OpenVSwitch community and discuss whether you really need that action, or is there a use, whether it's fine. And there are certain steps involved, like once it is fine, then it is just follow a particular flow, like see the existing OVS code, add the code to encode, decode, and then finally implement your action. You may need to implement a datapath action as well if it requires. Okay. Okay. This is just to reiterate the fact, just discuss with the OVS community once. Okay. First, let's see, how a flow is added. Like you have a controller which is talking to OpenVSwitchd, right? They talk using OpenFlow protocol. So the OpenFlow protocol can be 1.0, 1.2, 1.3, and you can use a utility like OFCTL to add a flow. So either of whatever you do, you would basically specify what is your match action and what is your match and what is your action. So this particular flow needs to be translated and sent to the Ovs-vSwitchd. And Ovs-vSwitchd actually talks in OpenFlow wire protocol. So you as an OVS developer, like you need to add the code to parse those actions and convert them into ofpacts. Actually, there is something called ofpacts in OpenVSwitch, which is nothing but like it represents each action internally, independent of the OpenFlow action, so that you can OpenVSwitchd can support multiple OpenFlows. So that's one thing, and then it actually converts those ofpacts into actual OpenFlow action, and then it sends it to the Ovs-vSwitchd either via TCP socket or Unix socket, depending on, like if you are writing a controller, you would be having a TCP session with Ovs-vSwitchd, and you would send it in the OpenFlow format. And then Ovs-vSwitchd will receive that particular flow at I think I skipped it. Okay. Yeah, so Ovs-vSwitchd will receive that. It decodes from the OpenFlow action back to ofpacts, and it stores it. So after that, it never uses OpenFlow actions. It only uses the ofacts. It's like it will have a big table, a cache table, rule classifier, which it is called, and it stores all the flows. And it will, when a packet comes, when it does a flow translation, it looks into that, figures out those actions, and then frames, and then it converts into datapath actions. Okay, we can check into that later. Okay, so this is just an example. In our case, like we thought that we'll add an action called check packet larger, which would take the packet length and and store the result of that particular evaluation into this register bit. Like OVS has something called registers. These are like scratch pad registers, like variables you can think of, and it is valid for your pipeline. You can store whatever you want. You can store IP4 address, whatever you like. You can store. That will be like temporarily stored. And later on in your flow table, you can say that if this particular register is set, do this, and so so this is how like sorry about that. Okay, so this is how like it looks like. So, I mean, from an OFCTL point of view. So you need to add certain code in this section of OVS saying that first of all you need to say this is how my ofpact will look like. And if you see the structure here, I mean, for this action it only needs two input variables. One is the length, what it wants to check into, and where it wants to store the result. So this result will be like a register bit. So it is represented using MF subfield. So this subfield is like, yeah, each register will have a code, and it stores that information. Like in that particular register, which bit or what are the subset of bits, stuff like that. So we need to basically store that information. So you need to add a code to store that. So if you are adding in some other action, you need to take care of defining in a structure similar way and storing it. And of course, you need to also add the open flow representation of your new action. So which would look something like this. You need to add in this file called OFP actions. If you look into this, there is a big enum for each and every action of OVS. You will find an entry here, and you need to add a corresponding structure. So these all informations are very much like what length it is and what is the type and stuff like that. And finally, you would store the packet length and register offset, and your actual register header will be stored in the structure. So this is the format which ultimately your controller will send it to OVS. And then you need to like add the code, do parsing, and basically parse. Yeah, whatever you enter, you just parse and store it into the ofpact. So in the case of OVN controller, this is I'm just giving an example like how it uses it. So it basically uses this code and sets the length it wants and sets the register. And then finally, like after we parse, we need to encode those into actual open flow structure, which is this. So here is the code. So if you see the OVS code, there is a kind of a big generic function here which does the encoding for each different action type. So you need to implement this function. So basically, as soon as you add, OVS will generate certain code, or it expects you to implement. If you don't implement, you'll get compiler errors. So you need to add that and implement. So as you can see here, it just stores the packet length and the register information. Okay. So and then finally, we also need to decode. Like when Ovs-vSwitchd receives that message, it needs to decode. So it decodes from the open flow structure into ofpact structure, and it like stores. And then it adds this into the flow table in its classifier so that it can be retrieved later. Okay, so fine. So we talked about just the initial adding. So that is encoding, decoding. That's simple. And then comes actual implementation of this action. Like in the case of OVS, all the registers are they're only in the user space. They don't translate into datapath action. So what I mean to say is that like when there is a miss, the packet goes to Ovs-vSwitchd and it runs the translation, and then it again has to push back the flow. So if you take this as an example here, I have a simple flow here. I say that if it's an IP packet, I'm incoming, and if it is coming from this import, apply this action, which is check the packet length and store the result of that packet length into this particular register and go to table 1. And in table 1, if that particular register bit is set, output the packet to port 3, otherwise output the packet to port 4. I mean, it's a simple thing. And how the translation happens is that we push a packet to the datapath saying that this is the packet length, and see for this size, and suppose if the packet length is greater, you apply this action. If it is lesser, apply this action. Like Ovs-vSwitchd will internally, okay, I think I have slides. Yeah, so if you see, it might be small, very small maybe probably, but this is what the translation code looks like, wherein you store the packet length, and basically you set the register value and do the it's like a function call. You just set a value of that particular register set, run all the translation, come back, and then set the register value back to 0 again, and then compute. It's like two paths it can go. What if the register bit is set, what actions to apply? So translate those actions, then come back and then set the register value to 0 and see what actions would be applied in case if the packet length is lesser or equal. So two paths are calculated, and the flow is pushed to the data path. Yeah, and when the actual packet comes from, if the subsequent packets come, they don't hit it would hit the fast cache in the data path, either in the DPDK or in the kernel data path, and the data path implementation of this action would check the packet length. If it is greater, it retrieves what actions to apply. It's like a netlink attribute, and it applies those actions. And if it is lesser, it will apply the other actions. So that way, the whole of the flow, as long as it is cached inside the data path, the packet will not come to user space, and it will be handled either if the packet is greater or lesser. So going back, so this is like how the user space implementation, which will be used like for the DPDK. Like in the case of DPDK, the packet translation happens. The Ovs-vSwitchd translates what are the actions to apply for that packet and encodes it in the netlink format. And then the packet will go to the, I think, DPIF netdev. So that is the one which hits for DPDK, and then it will internally call ODP execute. There is a file called ODP execute.c which will have the user space implementation of all the actions, like if you want to set IPv4 source, destination, whatever. So, and this code gets hit, and this will like check the packet length. If it is greater, it will retrieve the actions to be applied. If it is greater, or it will retrieve the actions lesser, and then it calls recursively again ODP execute actions.
The previous one was related to the Xlate related code was related to the kernel data path, right?
No, actually, yeah. So this is just like once this implementation is done. Oh, by the way, I forgot to mention that whatever I'm talking about, these actions, like they have been submitted as an RFC patches to the OVS community. They are still under review, and they have not merged it. So just a disclaimer. Okay, so here what I want to see is that how OVN uses it. How OVN uses it. I mean, this is giving an example like where you have two logical switches, which is nothing but your virtual networks, and they are like connected to a router, and there is a public network which provides the external connectivity, and you configure here saying that for this particular LR0 public, which is the router interface for your gateway, the MTU is 1500. So if this is set, what OVN would do is it will generate these logical flows. Sorry for the font here. It basically generates this logical flow saying that check this packet larger and store into this register. So, and in the next table, and then it does a next. It goes to the table 10, and here if that particular bit in the register is set, then it would frame an ICMP reply packet saying that you need to defragment the packet to a lesser size, and that MTU is included here, ICMP4 fragment MTU 442, so that the sender VM gets the ICMP. Actually, sender VM's kernel will get the host kernel will get this ICMP packet, and it will defragment and then send the packets. So it will be handled by the host kernel itself. So this is how OVN uses it. So I think we are early a bit. So just to summarize that, we just discussed like how we can add a new OVS action in OVS, and what are the steps required. I think so. That's it. If there are any questions, yeah.
This thanks for presenting. So this OVS is used for OpenShift in the Reddit, right? This is
OVS is used in it is used in Kubernetes, OpenStack.
Yes, yes. So my question actually a little bit related to the not exactly same. Actually, there's multi CNI support in that. What you are actually you are planning for this, or it is like only one CNI is the?
I don't know too much, but in Kubernetes or OpenShift, we'll be using OVN for the normal container flow, and maybe Multus could be used.
Because that will affect the DPDK actually environment in that.
Yes, I mean, so this is just from an OVN point of view, but if you want faster thing like SRAO, probably I think the Multus could be the networking CNI plugin which could be used. I'm not too familiar about that.
Thank you.